This video is going to talk about solving equations with balances. So we have here an expression for the number of apples on the side with a paper bag. They want us to write an expression. Let's say that the paper bag is the letter X. We know that there are X apples in the bag. How many is X? But we know that there's X plus 2 apples on this side. On this side, there are 1, 2, 3, 4, 5, 6, 7 apples. If there are the same amount of apples on both sides, then what we're going to do is we're going to put an equal sign. X plus 2 equals 7. How do we figure out how many apples are in that bag, that super legit looking box bag? Well, we're going to keep the scale even. This right here is a scale. It is the best scale you will ever see, so you're welcome for that. We have to keep this scale in balance. If we take an apple off from one side, it's going to become unbalanced unless we take an apple off from both sides. So, take an apple, take an apple, take an apple, take an apple. We have subtracted 2 from this side and subtracted 2 from this side. So on this side, we just have X. On this side, we have 7 minus 2, which is 5. So our answer, the number of apples in the X, is 5. An equation is like a balanced pans or scales. Scales stay balanced and they are completely equal on both sides. Of course, like the thing that I've just drawn. You're welcome again. So you can see here that they took 2 away from both sides to make that X equals 7. Over here, how many apples need to be subtracted from both sides of the equation? We have a box plus 5 extra apples just kind of rolling around means that there's 9 total apples. Well, we need to get rid of the 5 loose apples. So we're going to subtract 5 from this side and subtract 5 from this side. And we're going to end up with X equals 4. Because we've taken these apples away, so we're just left with X. 9 minus 5 is 4. You go ahead and try the other ones, pause the video, and we'll talk about it when we come back. Welcome back. So let's take a look at letter B. Letter B, we have N plus 17 equals 23. We have 17 loose apples rolling around, so we need to subtract those from both sides to make sure that these scales stay balanced. We're done with this. So N, we could write N plus 0, but who's going to do that? Equals 23 minus 7. Oh boy, I need to borrow. 13 minus 7. Oh boy, that's going to be 6. N equals 6. Letter C, you have 14 rolling around apples plus however many is in the letter N makes 17. So subtract 14 from both sides, because those are the ones that are rolling around, and you're going to be left with N equals 3. Letter D, P plus 15 equals 21. We have 15 apples that are loose. Subtract 15 from both sides, and you end up with P equals, well, I know that 15 plus 5 is 20, so 15 plus 6 is 21. Now they want you to help them show the work. What happens in letter A, X plus 15 minus 15 equals just X. So what do we do in letter B? What do we subtract away from letter B to get just X left over? Correct. We're going to take away the 55 because these will cancel out and they'll just be X. What about over here? X plus 91. Well, if we just want the x and not the 91, let's take away the 91. What about over here? This says x plus 38, and they just want 38 left. So what do we take away? We take away the x. Most times you won't need to be doing that right now, but later on in the future it may become important. So they want you to solve these problems. Go ahead and give these problems a shot on your own, and when you come back, we'll talk about it. Welcome back. For letter A, x plus 5 equals 14. We have x plus 5. Take the 5 away. Excuse me. So the equation just tells you what x is. Now is a great time to have the hiccups. 14 minus 5 is 9. So here, x is 9. We can double check that by putting 9 in for x. 9 plus 5 equals 14. We did it. Let's take a look at letter B. X plus 9 equals 21. Well, let's go ahead and subtract 9 away so that we just have x, because 9 is on the same side as x. X equals 21 minus 9. That is going to be 12. So we have x equals 12. Letter C, we have 2 plus x equals 35. Well, I need to get x all alone, so I know what x equals, so I'm going to get rid of the 2. Subtract 2 away. X equals 33. And then our last one, x plus 28 equals 54. I'm going to subtract 28 away from both sides, and I'll be left with x equals, if I can't do this in my head, I should show the work for it. Can't do 4 minus 8. 5 becomes 4. 14 minus 8 is 6. That becomes 26. X equals 26. These scales are balanced. Each bag has the same number of apples in it. How do we figure out how many apples are in each bag? So if we look, there's a nifty hint down at the bottom that tells us we can cross off whole bags too. So let's cross off everything that's on both sides of the scale, because we know that we can take both of those up without the scale overbalancing. So I see an apple here. Goodbye apple. Goodbye apple. I see a bag and a bag. I'm going to cross off one of those bags. And I'm left with 2 apples is the same as 1 bag. 2 apples equals a bag. Remember that the pans of the balance become the sides of the equation. The equal sign is what's right here. So they want us to write the corresponding or the matching equations for the model shown using the letter B for the unknown number. Well, first of all, no. The letter B, if you write it quickly, can very easily look like the number 6. A lot of letters can be mistaken for this. Capital I, is that a 1? Is that a lowercase l? Is that a capital I? Who knows? There's a lot of letters that can be very tricky if you're not careful. So in order for us to make sure that we're being clear, I would probably use a capital letter B. However, if a problem tells you to use a variable, you have to use that variable without switching it around, because there can be a difference between a capital and a lowercase. Anyways, letter A, there are 2 bags. So I'm going to say 2B, making sure that that's a very clear B. And there are 1, 2, 3, 4, 5, 6 times 2 is 12. So I know that 2B equals 12. Or if I was to separate these into 2 groups, I would get 1 group per bag. So I divided by 2. Divide 2B by 2, divide 12 by 2. B equals 6. There are 6 circles in each bag. Watch as the rest of these slides probably walk you through that. Oh no, they don't. Fantastic. Let's take a look at this equation. You try writing this equation out. Welcome back. We have 1, 2, 3, 4, 5, 12 circles and 4 bags, 4B. So what I'm going to do now is I'm going to take those circles. There are 4 bags, so I'm going to divide by 4 on both sides. So I'm going to put these into circles of 4 so that I know there are 3 for one bag. 4 divided by 4 is 1. 12 divided by 4 is 3. Let's go ahead. They want you to draw the models and use them to solve the equations. You can absolutely do that. I will draw the first model, but then I'm going to show you how to draw the model using math. So the first model is bag plus bag, bag times bag times bag. There are 3 bags. 3B, or bag plus bag equals 15, which means I'd put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15 dots down. And when I put 15 dots down, what I'm going to do is I'm going to separate those 15 dots into the 3 bags. So I have them in 3 groups. Or I could divide 3B equals 15. I could divide each side by 3 and get B equals 5. And there are 5 dots per bag. You try solving the next one in whatever way works for you. I'm going to show you how to do the math version when we come back. Welcome back. So for letter B, we have 4B equals 8. So because I'm multiplying, there are 4 B's there, I only want 1. So I'm going to divide each side by 4. And I'm left with B equals 2. Letter C, there are 9 bags. So I'm going to divide each side by 9 and be left with B equals 2. Letter D, there are 7 bags. Divide each side by 7. B equals 3. So the mathematical operation we used to write the equations, just writing the equations, was multiplication. To solve it, we subtracted. Well, I'm sorry, we divided. I'm getting ahead of myself. Did you notice that in the addition problems, we used subtraction to solve? These are called inverses. Multiplication and division are inverses. Addition and subtraction are inverses. It's kind of like the way of saying the opposite operation. Remember that order doesn't matter in multiplication. If I say 3 times 4 or 4 times 3, either one is going to be 12. Letters represent numbers that you don't know. So anything that works with numbers will work with letters too. We can say B times 3 or 3B. So they want you to rewrite this without the multiplication sign, and they want the variable to be the first factor. Mathematically, you typically write it without the multiplication sign, with the letter first. However, it's not wrong to write it as B times 3 equals 18. B times 4 equals 16. B times 9 equals 18. B times 8 equals 21. Now they want you to solve these equations. Remember that you solve what's inside the parentheses first. Go ahead, give this a shot, and when you come back, we'll talk about it. Welcome back. 5 times 2 is 10. 10 divided by 2 is 5. 8 times 2 is 16, excuse me, don't look ahead. 16 divided by 2 is 8. 9 times 3 is 27. 27 divided by 3 is 9. You starting to see a pattern here? Do you see how when we multiply and then divide by the same number, we end up getting the same answer here? If you take a number and you multiply it and then divide by it, you're going to get the same number that you started with. So what are we going to get here when we perform the multiplication and then division? This is going to be literally square, because we don't know what the square is. We just know that that's what they put in there. So what's the answer going to be for these? Yeah, it's going to be the letter B. So they want to say what number, if I'm multiplying by 7 here, what do I divide by just to get the letter B? Well, B times 7, I'm going to divide by 7. B times 2, I'm going to divide by 2. B times 4, I'm going to divide by 4. They want you to write the equation in this balance. This says 3 groups of 5. 3 groups of, not of 15. I don't know where that's going, but you know, that's okay. 3 times 5 equals 1, 2, 3, 4, 5 times 3 is 50. Hey, look at that. 3 times 5 equals 15. Now, if we divided each one of these by 3, we divided this into 3 groups, and we divide this into 3 groups, we're going to get 5 apples in each group. B equals 5. So go ahead and solve these problems. This time they absolutely want you to use the mathematical way of solving instead of the pictures that you might have used last time. Go ahead, give it a shot, and when you come back, we'll talk about it. Welcome back. B times 7 equals 21. We're going to divide by 7 on both sides. B times 7 divided by 7, that's just the letter B. 21 divided by 7 is 3. Over here, B times 4 equals 20. We're going to divide by 4 on both sides to keep the balance equal. B equals 5. Right here, we have B times 3 equals 27. We're going to divide by 3 on both sides, and we're left with B equals 9. Letter B, divide by 2 on each side. B equals 6. Letter D, divide by 6. B equals 7. Letter F, divide by 9, and you get B equals 8. Ladies and gentlemen, I hope that you have an absolutely fantastic day.